So we are going to try to figure out zero exponents. I teach one method in the MBF3C course in lesson 4. So if you want to check out that video, there's one method there that talks about exponent laws and talks about zero exponents and how they work. We're going to look at another method to try to understand what is going on with why zero exponents do what they do. So we're going to use the example of 2 to the x. So we're going to do a table of values to see what the pattern is and what's happening with 2. So y equals 2 to the x is what we're looking at. So we have our x and we have our y. So we're not going to start with 0. We're actually, let's start with 5. So we're going to say, okay, so if x is 5, then y is 2 to the 5th, which is equal to 2 times 2 times 2 times 2 times 2. 5 2s, which is equal to 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that equals 32. Okay, so then let's say, okay, well, let's do 2 to the 4th. So that's 2 times 2 times 2 times 2, which is equal to 16. 2 to the 3rd is equal to 2 times 2 times 2, which is 8. 2 to the 2nd, 2 squared, right? If x is 2. So then we have 2 times 2 is equal to 4. And then x is 1, so 2 to the 1 is equal to 2 times nothing, which is equal to 2. Okay, hopefully all of that makes sense in terms of how exponents work. And now the next one we want is going to be x to the 0. So then we have 2 to the 0, but it's like, what? What do we even put there? If we have 2 to the 0, we don't have any 2's. So how do we even do that with our multiplication? That doesn't make any sense. So what we're going to do instead is we're going to look at the pattern that's happening over here. So if you do on your calculator, if you do 32 divided by 16, we're going to see that 32 divided by 16 to figure out what your ratio is there, what's going on there. And that is equal to 2. Okay, that makes sense because we had one extra 2 that we multiplied here. So if we divide them, we have, it's 2. Okay, so the same with 16 divided by 8. That is going to be 2. Okay, so then we have 8 divided by 4. And that equals 2. Hopefully you can see the pattern that it is happening. And that's what exponents means, is that we're increasing by a constant ratio. We're increasing by 2 each time. That makes sense. That's what we did in our multiplication. So 4 divided by 2 is going to equal 2. So then if we want to keep the same pattern, well, we're dividing by 2, or we have a difference of 2 each time. Our ratio is by 2 each time. So we could also think of it in a different way. We go, okay, so to figure out what our previous number is, so if we do 32 divided by 2, that's going to give us 16, which is our next number, right? We do 16 divided by 2, that's going to give us 8, which is our next number. We do 8 divided by 2, we get 4. That's our next number. We get 4 divided by 2 gives us 2, and that was our next number. So if we want to figure out what our next number is, here if we do 2 divided by 2 equals 1. So our next number is going to have to equal 1 because we're following that same pattern, right? Where we have a common constant ratio of 2, where every time that we increase our exponent, we multiply it by 2. So every time we decrease our exponent, we divide by 2. So that means that when we go from, if we want to go from 2 to the exponent 1 to 2 to the exponent 0, we need to divide 2 by 2, which is equal to 1. So let's set that in. Does that make sense? So then let's do another example. Let's do 5. So y equals 5 to the exponent x. We're going to still do our table of values to organize our information. So let's not do quite as many. So let's do 5 to the exponent 3. So that's going to be 5 times 5 times 5, which is going to be 5 times 5 is 25, times 5 is 125. And then let's say x is 2, so 5 squared equals 5 times 5 equals 25. X to the 1, 5 to the power 1 is just 5, which is just 5. And then what's going to happen for 5 to the exponent 0? So again, still, we can see that we're decreasing by a factor of 5, right? So we're dividing by 5 each time. If we do, that's our ratio, which makes sense. That's our base number, is our ratio. So 125 divided by 5 equals 25. And 25 divided by 5, because that's our ratio, that's why we're multiplying by each time, is 5. Okay, that gives us our number. So then, again, to figure out what 5 to the 0 is going to be, well, that's going to be 5 divided by 5, which is equal 1. So it doesn't matter what our base is, no matter what, we're always going to end up dividing by itself, because that common ratio, constant ratio, is the base number. And so we always end up dividing by itself to figure out what the base to 0 is. So it's always going to equal 1. So how we write that is we say y equals b to the exponent 0. I guess we don't need the y equals 0. Sorry. Refresh, erase that. How we say it is we say that b, your base to the exponent 0, always equals 1, because you're always, in this pattern, you're always going to do your base divided by your base, which always equals 1 whenever you're trying to find the 0 exponent. All right, let that sit with yourself for a little while. If you have any questions, please let me know, and we can hopefully figure it out from there. Good luck.